truth.
So we can run the script here. And put key and controller from Python.keyboard at the top. Make a variable called keyboard and set it to control.
Yo. Okay. Alright, that's kind of sick though, I'm not gonna lie.
So today I'll be explaining how I made my knock on the table to pause the YouTube video on my laptop design. So the reality is this isn't a great idea or very practical, but I do believe that having the motivation to do something fun or interesting is a great way to learn and expand your skill set. And that's also the reason why I wanted to dedicate this video to explain the higher level objectives of this design rather than the detail design. In other words, I want to establish a toolbox that you can use for other projects in the future. Throughout the video, I'll be giving key terms and phrases that you can search to help look up documentation or other videos to help recreate the project that I'm doing right now. Although if you really do get stuck, I probably will be making more videos in the future about detail design and possibly post stuff on my GitHub. As a disclaimer, I'm not an expert in any of the things I say here, so don't quote me in like a lab report or something, because that'd be pretty bad. So the four main objectives are gathering raw data from sensing the environment, interpreting and understanding this data and knowing which parts are significant, as well as processing this data to a more relevant form of information. Next is communicating information between devices, and then finally completing an action or task. So first, sensing. What you want to ask is, what am I trying to detect? And once you have this complex idea, you want to break it down into its fundamental concept. For example, I want to detect knocking. That can cause vibrations, and that can be measured in acceleration. So maybe use an accelerometer. However, in certain cases, you might not know how to break down a complex idea. So you can perhaps start with the types of sensors that exist, see what they do, and then find a way to apply it to your current context. In my case, I did a little bit of both. I recently bought an accelerometer, and I wanted to use it for some application. But the main point being engineering design isn't a linear process, so do whatever you see fit. So the module I've used for this project is an IMU, or inertial measurement unit, and here's the model that I've bought. An IMU consists of a gyroscope, which measures angular velocity, an accelerometer, which measures acceleration in the three main axes, and a magnetometer, which detects magnetic fields. In most cases, an IMU is used to determine a body's orientation in three-dimensional space, utilizing all three sensors. However, for this case, I only care about the accelerometer. When I tape the accelerometer to a desk and I knock on my desk, it causes acceleration values to change, especially in the z-axis. Therefore, I've converted a complex idea such as knocking into acceleration values. Here are some key terms that might be useful to get started with. However, I do want to draw attention to the last point. Looking at projects that are similar is actually a really great way to learn, because in order to modify the code to apply it to your own situation, you have to have an understanding of it. It's also a great way to generate new terms that you can use to help look for documentations in the future. So now moving on to interpretation. We have all this raw information coming in, but which parts are relevant, and how do I use it to detect what I need to detect? In other words, we're moving backwards from fundamentals to a more complex idea. In my case, I'm wondering, how can I use acceleration values to determine if a knock has occurred or not? This graph is a very simple representation of acceleration values being reported by the IMU. If the accelerometer is moving up and down the z-axis, you can see that there's variations in acceleration, some of which are small and some of which are large. Going into more detail, if we constantly take the difference between acceleration values of 2 times right next to each other, if we see a very large difference, such as 0.8, we know that a very sudden change in acceleration has occurred. However, there are still small fluctuations in acceleration, such as this 0.3, which aren't caused by my knocking, and I want to filter these out. A simple way to solve this is with a threshold, and I say that if a difference in acceleration is greater than 0.5, then a knock has occurred. The second part is detecting the right rhythm. Depending on the rhythm you choose, the time separating the knocks will differ. Therefore, all you need to do is check to see if the difference between 2 knocks is within a certain time range. You then apply this check to the latest few knocks that have occurred every single time a new knock appears. Playing around with the range is important, because if it's too small, it gets too difficult to get the correct rhythm, and if it's too large, then there's a lot of cases of false triggers. Once again, here are some useful keywords and concepts that you may want to look into. This part is a lot more based on the fundamental knowledge of coding, so depending on your level of knowledge, it may or may not be useful. However, I do still want to draw attention to the last 2 points about arrays and the mod operator. In particular, it's probably going to be useful for rhythm, especially for storing the time of the knocks. The third part is communicating the information. When using a microcontroller such as an Arduino, these are some terms that you can probably look into. However, since this project doesn't send serial data through the COM ports using a wired connection or Bluetooth Low Energy, I won't be talking about these. How I do this is actually through Wi-Fi, and this is the microcontroller that I've used. The way I do this is through a web server. With my microcontroller connected to the internet, I access the web server that I've created through its URL domain. I then access that PHP file that I've created and uploaded to the web server's file directory and do something called an HTML post request from my Arduino code. The PHP file is then able to detect when a post request has been made, and then it sends whatever information it receives and stores it in the database. The PHP file also gets the information from the database and then writes it to a JSON file, which is also on the web server's file directory. With a Python script on my laptop, I'm also able to access the web server's JSON file and then download whatever information's in here. Therefore, I have successfully transmitted information from my Arduino to my laptop without a wired connection. In this context, I'm constantly updating the correct number of knocks that have occurred. Once again, here are the key search terms, and this was probably the most difficult part of the whole project for me. The free web server hosting service I've used is 000 web host. So the final part is action, and this is probably the most straightforward part, as well as the part that is most subject to change. Once you have the data, you can do whatever you want with it. Turn on the lights, send an email, process the data and send it back to the web server. In my case, once I've detected that a change in the number of knocks has occurred, I use a library in Python called PyInput, which will press the space key on my laptop, and that's how I pause and play the video. Anyways, that's pretty much it. Once again, I might be making more videos on the detailed design, which you probably might need because it was very vague in this video, but I do believe that struggling is an important part of learning. The reason I'm doing this is really just to motivate myself to learn, as well as perhaps teach other people along the way. Whether or not you actually did, I don't know, but yeah, have a good one.